Okay, in this video, it's freezing cold over here in the room. They didn't fix the heater. That's the reason I'm wearing this cap. All right, in this video, I will show you how to graph the data, Y position versus X position of the projectile. You type this data that you got from the simulation, watch the previous video on how to do that, and now we show you how to graph this data and fit a quadratic function into this data. So click a blank cell, go to Insert, Chart, and always select the scatter plot. Scroll down till you see the scatter plot. It defaults to column chart. You need to change column chart to a scatter chart. The data range, as you see, is from A2 semicolon 816. You might have more numbers than this. I think I missed like 5 numbers from the data. And then comma, and the same thing, B2, B16. I've seen students getting up to 22 points. It's depending on your angle and depending on how many you did. When you hit enter, you can see that this is the quadratic or parabola. Now you go and fit a quadratic function. So before doing that, the title, I want you to put what the initial velocity was, 15 meters per second, and I ask you not to change that, but the angle in my case is 35 degrees, and I ask you to use another angle. All right, so close that, go to series. Let's put the axis, horizontal, X in meters, vertical, Y in meters. All right, so we finish everything in chart and axis studies. Underneath, go to series. I personally like the points black and smaller inside, but that's not important. And you click a trend line. Obviously, this is not a trend line. This is a quadratic function, as I show you on the paper, in the derivation on the paper. So a quadratic function is polynomial 2 and defaults to 2, so you don't need to change that. And then scroll down and select display the equation over here. So now this is complete, and now it is very important for the calculation of G that you get this value over here, 0.0322, that is multiplying x squared. That's the number that you need to calculate G.